Meteorologist Jim Rinaldi here for Lebanon County weather. I want to take a look here at this system that's coming up for Monday that Justin alluded to in his text discussion. I want to show you some things that are going on here, and I think the models are starting to catch on to what's going on with this storm. And a big key for this is going to be these sea surface temperatures. These are the sea surface temperatures anomalies as compared to climatology, and this was done early this morning, actually, about 1 a.m. These readings were taken, and you can see here, right along the Jersey coast down towards Maryland and Delaware, some very, very anomalously warm sea surface temperatures, and it's warm out here. Now there is some cooler water out here off Virginia and Delmarva, but once you get up in this region here, you have some very warm sea surface temperatures, and that is going to be a key, because what's going to happen is there's going to be an air mass gradient of temperature, but then that sea surface temperature gradient is going to add to that as well. Now here's our storm forming here. This is 72 hours. And this is valid on Monday morning, and you can see kind of a blob, very disorganized area of low pressure here. But notice here we have this temperature gradient of the air mass. You can see here these temperature lines are pretty tightly packed in here. Yeah, it's a pretty good gradient in there. Keep in mind, those very warm sea surface temperatures, though, are going to make that gradient. This is just the air temperatures. That is not accounting for those sea surface temperatures. So there's going to be an even tighter packing of temperature gradient when in this region here where those very warm waters were. We'll go out here to 78 hours, and now you can start to see, here's our storm starting to form, a little bit stronger now. Yeah, now is the defined center of low pressure right here. Here, look at these packings of the isotherms are getting even tighter up in here, and keep in mind that sea surface temperature anomalies, those are going to create an even stronger gradient for you up in there. We'll go ahead here to 84 hours, and now our storm is really wrapping up. We got 1,000 millibars here over eastern Massachusetts, Rhode Island, somewhere in that area in here. Right here, obviously, is our area of low pressure, and look at the track it's taking right along this tight temperature gradient, right in there. It's following that right along, and that's what storms like to do. They like to follow that gradient. So that's why I've been seeing people talk on Twitter and such about how the storm is going to be further east, and it's going to trend east, and it's going to be cold. It's going to bring snow to the coast and all this stuff. No, that's not going to happen. Storms like to follow that temperature gradient, and it just makes sense. I'll take you back here now. This was the run from yesterday morning, from Thursday morning at 12Z, and this map here is valid the same time this one is. Look at the difference between this. There's the 1,004 low there, and this. It's 1,012. It's well offshore. It's not showing any real organization here of any kind. Now also here, I want you to notice here now, if anybody notices this here, here's our temperature gradient on from yesterday's run. It's kind of dispersed and all that, and here's the one from today, much tighter packed. I think the model is sensing that the sea surface temperature anomalies, and it is it's catching up with itself, basically, is what it's doing. So somebody say, well, the gradient is tighter here because the low is stronger here, and that's why. No, I think the low is stronger because the model is sensing those the sea surface temperature differences. And so therefore the low is stronger, and because the low is stronger, that's why then the surface temperature gradient is stronger as well. And here is the from yesterday's run. Here it is at 18Z Monday, and again much weaker. You remember we had on the today's run, we have that 1,000 millibar closed circulation low up in here. That we have the low pressure that's up in here like this. So a much different look today, and I think the models are catching on to it. Another factor too is we have energy that's coming in to those anomalously warm sea surface temperatures. So here's a short wave down in here, this area here, right in there. That's some energy coming in, and that's going to come up into the out into the waters. Now, like I said, it is cold. The water is a little colder off the Virginia Capes, but as this continues to advect to the north and east, it's going to hit those warmer waters, and that's why I think you're seeing the low pressure system intensifying more than what the models were showing yesterday. So as far as what all this means preliminarily, this is nothing written in stone. But what I'm thinking is that that's going to set up, mostly rain for these green areas here. I think you're looking at a storm track, that's going to be coming up. I think the GFS may be a little bit too far west, not by much. But I think you're looking at low pressure coming out like this here, and then up like this way here. So that's kind of what I'm thinking. So that would give you mostly rain for this area, for the green areas. I think the areas in pink here, you're going to have a mix of rain and snow. Mostly rain further east, south, and east. A little bit more snow north and west. And then once you get north and west of this line here, you're looking at mostly snow. At this point, it looks like, maybe 2 to 4 type of event, 3 to 6 for some areas. Maybe some places pick up more, a little bit less. Models are not very consistent on that right now, but that's what I'm currently thinking right now, as at least to where the zone's set up as far as rain, sleet, rain, mixed snow, that type of thing. So that's what I wanted to show you. I am meteorologist Jim Rinaldi for Lebanon County Weather.